we have ensemble techniques, and ensemble techniques are used basically to solve the variance bias trade-offs. Point number one. Point number two, the basic premise here is to use multiple models or techniques and then combine the results into one. This is the basic premise with which ensemble algorithm proceeds further. Ensample means the data which is in training, which is used to train your model. Out of sample is that data which is not in your training, which is test data. In sample is also called as in bag. Out of sample is also called as out of bag, which is also called as OOB. Okay. Next. Ensemble techniques can be used for all of these purposes: diagnostics, regression, classification, survival, time series, so on and so forth. It works well usually when you have large data set and nonlinear data sets. Then it has two steps. One is building the model, another is combining the model. Ensemble means multiple models. You build multiple models. Then what is the next step? Combine the results of all of those. These are the two things, right? So base learner means the individual algorithm that you're going to run. If you use the same base learners, so if you say that I'm going to use only decision tree algorithm, I have data. I'm going to split this data into training and test. Okay, and then I'll build a model, decision tree 1. I get some accuracy, say 90%. Again, I'm going to split this data into training and test. Again, I'll build the model on training, test on test. So I have decision tree 2. Probably this will give accuracy of 80%. Again, I'm going to split the data into training and test. Build the model on training and test it on test. This is decision tree 3. Again, I'll get some accuracy. How can I combine these results? By taking a simple average. 90 plus 85 plus 80 by 3 will give me a simple average. Okay. If you use the same algorithm throughout, it can be decision tree algorithm only, it can be KNN algorithm, it can be any other algorithm. If you use the same algorithm to train on each and every split, then it's called as homogeneous ensemble model. But sometimes you might say that on this first split, I will run support vector machine. Second split, I will run decision tree. On the third split, I'm going to run neural networks. So if you use different algorithms on different splits, and then if you want to take average of the accuracies, it's called as heterogeneous because you're using different algorithms. You're using different base learners. Those individual algorithms are called as what? Base learners. Okay. All right. Give me a minute. If I just checking whether I can get some additional information for you guys. I made a note of all the important things. I don't want to miss out on anything. In sample, out of sample, we discussed. Okay, and one more thing is the reason behind splitting the data multiple times is each time when you randomly split the data, maybe the kind of observations that you get in training and test might not always give you a good model. Your model building means what? Learning the patterns in your data. I have the overall data. When I split that into training and test, I cannot expect always good quality data to be in training, good quality data to be in test. Each time I split, the kind of accuracy that I get also depends on the observations that I have in training and test, because ultimately a model is learning the patterns. What if your split is very bad or very different? Randomly you're splitting. I'm not at all discounting the thought that you're randomly splitting. But sometimes, very rarely, it might so happen that training data might be very different to your test data. So when you build your model on training data and test it on test data, you might get bad results. Sometimes your training and test data might be so close to each other, perfectly maybe it is split. And hence, when you train your model and test on test data, your accuracy is very high. Can you expect that always? No. To remove that 1% chance or very small percentage chance of having very good data, very good split into training and test, or very bad split into training and test, you split it multiple times. And you run the model multiple times so that you bring in some kind of consistency into your model. That's another reason why we build multiple models multiple times by splitting it multiple times. Okay, that's one more point that you will have to remember. And in sample, out of sample is done. Okay. One more very important thing is we have something called as generative versus non-generative algorithms. Generative versus non-generative. Okay. Write down. When I'm explaining about a concept, don't assume you'll remember everything. You're not robots, so please make a note. Okay. Generative versus non-generative. Okay. When it comes to non-generative algorithms, you have two things. One is called as voting. Okay. Another is called as stacking. Okay. So stacking, we will deep dive. Voting also, we are going to deep dive. So I'll just hold on rather than explain more things. And here, generative are your boosting models. Suppose you are running homogeneous algorithm. If you're saying that run this algorithm 10 times, what will it do? It will split the data into training and test 10 different times. And it will train 10 different times, test it 10 different times on the test data, right? Here, one algorithm versus another, there's no relationship. They're all standalone algorithms. If you're saying run algorithm 10 times, 10 different algorithms are built. Of course, they are all decision trees, but all these 10 will be trained on 10 different training datasets and tested on 10 different test datasets. So each one is different. You just combine the results of all the accuracies. Okay, those kind of algorithms are non-generative. But there will be algorithms where there'll be dependency of one algorithm on another. Say you split the model, you built one algorithm. Then next time when you split, The next split depends on the first algorithm results. How it will depend, all that we'll discuss, we'll deep dive. You built an algorithm, right? 10 times you need to run, first time you have run. Second time when you split the data into training and test, the second time when you're splitting, how you split depends on the first algorithm results. So when there is dependency of one algorithm on another, it is called as generative. From one, you're generating second algorithm. From the second, you're generating third algorithm. From third, you're generating fourth algorithm. Okay. So one algorithm, you understand what are the challenges. One algorithm, when you run, what are the challenges? When you split the data, again, it might give you completely different results. That's a challenge. Hence, what are we doing? We are resorting to Ensemble. Within Ensemble, we have homogeneous and heterogeneous. And here, generative versus non-generative. Here, bagging is also called as generative. Why? We will understand. And we have random forest. Okay. So you have generative, non-generative. In non-generative, you have voting and stacking. In generative, you have boosting, bagging, and random forest. Okay. So no, it can be heterogeneous also. But people don't usually do that. They go with homogeneous only. Why you can, it doesn't make sense. So they go with homogeneous. Okay.